Question 3. The marks obtained by 10 pupils in an English test were 15, 14, 12, 13, P, 16, 11, 13, 12, and 17. The sum of the squares of the marks, that is the summation of x squared, is 1794. Part A, calculate the value of P. 2. Standard deviation. B. If each mark is increased by 3, write down the new mean and the new standard deviation. Now, in this question, we have been given marks of 10 pupils. 1 mark or mark of 1 pupil is missing but is represented by letter P. But you have also been given the sum of the squares of the marks to be 1794. So if we square the marks and add them, we should get 1794. So our marks are 15, 14, 12, 13, P, 16, 11, 13, 12, and 17. Now, if we square these marks, if we square the marks and add them, we should get 1794. So 15 squared plus 14 squared plus 12 squared plus 13 squared plus P squared plus 16 squared plus 11 squared plus 13 squared plus 12 squared plus 17 squared is equal to 1794. So squaring them, we will have 225 plus 196 plus 144 plus 169 plus P squared plus 256 plus 121 plus 169 plus 144 plus 289 being equal to 1794. So adding on the natural numbers, we will have P squared plus 1713 is equal to 1794. This means that P squared is equal to 1794 minus 1713. So P squared gives us the difference between the two is 81. So our P will be equal to the square root of 81, which is 9. So that is the value of P. Now, before we answer Roman 2, we need to arrange our marks from the least mark to the highest mark. Now, our least mark is 9, followed by 11, then 12, then 12, then 13, 13, 14, 15, 16, and 17. Now, this is ungrouped data. So, for ungrouped data, the standard deviation is given by S is given by the summation of x minus mean squared over n minus 1, and then we find the square root. So for us to be able to get the standard deviation, we need to get the mean. Now, mean is given by total marks over the number, which is n. So our total marks will be, we have 9 plus 11 plus 12 plus 12 plus 13 plus 13 plus 14 plus 15 plus 16 plus 17 and then we divide by 10 because the marks were 10. So this will be equal to 132 over 10, which gives us the mean as 13.2. So with that, we can now create a table that will help us calculate the standard deviation. So from the formula of calculating standard deviation, we need a column for x, a column for x minus mean, and a column for x minus mean squared. So our column for x will be, we have our values or our marks, 9, 11, 12, 12, 13, 13, 14, 15, 16, and 17. Then we need a column of x minus the mean. And in this case, our mean is 13.2. So we take our x, which is 9, minus the mean, which is 13.2. That gives us negative 4.2. Then 11 minus 13.2 is negative 2.2. Then 12 minus 13.2 is negative 1.2. Again, 12 minus 13.2 is negative 1.2. 13 minus 13.2 is negative 0.2. 13 minus 13.2 is negative 0.2. 14 minus 13.2 is 0.8. 15 minus 13.2 is 1.8. 16 minus 13.2 is 2.8. And then 17 minus 13.2 is 3.8. Then now we need a column for x minus the mean squared. So the values we have gotten here, we square them. So negative 4.2 squared is 17.64. Negative 2.2 squared is 4.84. Negative 1.2 squared is 1.44. Negative 1.2 squared is 1.44. Negative 0.2 squared is 0.04. Negative 0.2 squared is 0.04. 0.8 squared is 0.64. 1.8 squared is 3.24. 2.8 squared is 7.84. 3.8 squared is 14.44. Now we need to get the summation of this. So we add all the values in this column and we will get 51.6. Now with that, we can get our standard deviation. So our S will be equal to the sum of x minus bar squared, which is 51.6, divided by n minus 1. So 10 minus 1. This is equal to, and then we find the square root. This is equal to the square root of 51.6 over 9, which gives us the square root of, dividing the two, we will get 5.733. So finding the square root, we will get our S to be equal to 2.394. Now to answer part B, we are told that if each mark is increased by 3, write down the new mean. So for part B, Roman 1, our new mean will be given by, if we increase each mark by 3, then the mean also increases by 3. So our new mean will be 13.2 plus 3, which is equal to 16.2. And then for Roman 2, we are required to give the new standard deviation. Now, if we increase each mark by 3, and a constant increase on the marks does not affect the standard deviation. Therefore, the standard deviation does not change and it remains to be 2.394.